Hey everybody, it's Miss Moran and I'm back to talk to you about partial products this week, and we're going to start multiplying with larger numbers, double-digit numbers, 2-digit by 2-digit multiplication. We're going to be using the partial products strategy exclusively. We are not going to be using a regrouping strategy at this point in 4th grade. At the end of the year, we may look at that as a getting ready for 5th grade skill, but that is not something we're going to be doing for now for a number of reasons. All right, so we are going to try to connect everything that we're doing with this skill to something we've already done. We're going to learn to apply a strategy to larger numbers, but we're not doing anything new mathematically. So this is a review of what we were doing last week, multiplying by large numbers, but large numbers ending in zeros means it's no more difficult because we're still just multiplying our basic facts. So for 40 times 30, we're going to multiply 4 times 3 tens, which is 12 tens. Anytime I'm multiplying times 10, it gives me one extra zero, 120. 4 times 300 is 12 hundreds. Hundreds have 2 zeros, 1,200. And for 4 times 3,000, 12,000 with 3 zeros. Okay, so that gets us to what we're doing this week, 40 times 30. Well, if 40 times 3 was 120, then 40 times 30 is going to have to be 10 times as big. Okay, so 10 times as big means I'm going to add one more zero. So tens times tens is 100, so we're going to need 12 hundreds, which is 1,200. 60 times 70 is 42. Again, tens times tens is hundreds, 4,200, 4,200. And 20 times 50, 2 times 5 is 10. Tens times tens are hundreds with those 2 zeros. And some students might look at this and say, well, we got 3 zeros here. We only have 2 here, remembering that sometimes basic facts end in zeros themselves. So I'm adding on 2 zeros every time I'm multiplying tens times tens, giving me hundreds. So we're going to use that as we get into estimating. We always want to make sure we're using estimation to help make sure that we're right-sizing our numbers. So 43 times 58, we're going to round. I'm going to take 43 down to 40. 58 is going to round up to 60. Okay, 6 times 4 is 24. Tens times tens is 100, so 2,400 or 2,400. So then when we get to this looks somewhat similar to this, but obviously we have 2 double-digit numbers, but one of them ends in a 0. So we talked about how we can approach this and how do we solve this problem when we're working with numbers that seem big, but maybe not necessarily that difficult. Well, we're going to say, well, it's easy to multiply 20. That's not the difficult number. The difficult number is the 37. So anytime our numbers are difficult, we're just going to break them up to make them simpler using the distributive property and using expanded form and place value. So we're going to break up 37 into 30 and 7, and we'll put 20 over here. So this is an area model, an extension of what we did last week. Basically imagining this as a giant array, only not 20 rows of 37 little counters. Which means we're going to break this up into doing 2 mini multiplication problems. So even though my numbers are big, they're not difficult multiplication. We've learned how to do that. So 20 times 30 is going to be 2 zeros for 600. And 20 times 7, 14 tens, which is 140. Those are called partial products, so I'll add my partial products together. My final answer is 740. Other students want to look at this and try to treat it as a regrouping model. And in this case, what makes this difficult about the regrouping is not the 37, it's the 20. It's that this is the double-digit number on the bottom. So we take a look at this and say, what if we imagined it wasn't a double-digit number? That 0 has no value there. So if we just treated it as 37 times 2 and did it as a regrouping model, that might be able to help us. Just like we do up here, we treat this as 4 times 3. All right, so 37 times 2 using regrouping. Multiplying my ones first, 2 times 7 is 14. Sorry, I hold my paper. And 2 times 3 is 6, plus 1 is 7. Well, that's 37 times 2. I need 37 times 20. It makes it 10 times as big. Multiplying by tens is going to give me one extra 0. So I have 740, doing that problem 2 different ways. One with the modified regrouping method, and one with partial products. So then the students say, well, what's going to happen when we have 2 numbers here that are kind of yucky, and none of them end in zeros? That makes it harder to multiply. And that's what we've been working on all week. How do we take a number, 2 two-digit numbers, that don't involve any zeros and make that a simpler problem? Well, we just break it up into tens and ones, same as we've done before. So this is my array. Sort of for purposes of scale, we usually make the larger factor along the larger edge of the rectangle. So we'll make this 60 and 3. This one over here is going to be 20 and 8. So we've broken up each of those numbers into their place values. That's step one of using partial products. All right, and then what this is so great about doing is helping students to see that there are 4 mini multiplication problems that have to be done. If I just wrote the problem this way, especially after teaching a regrouping method, students will want to multiply ones times ones and tens times tens and leave it at that. And there's more to it than that. There are 4 steps of mini multiplication, and just doing it like this, most students wouldn't see that. Doing it like this, it's very obvious, and they don't leave out any steps. They don't get confused on what needs to be multiplied first or second, or where numbers get regrouped, or what those numbers were before we added on other numbers in our regrouping. So this is great at just keeping it simple, multiplying by basic facts, and then modifying with some extra zeros. All right, so we can start in any order, doesn't really matter. That's what's great about partial products. I'll start here with my largest value. This square is always going to be the largest value because it's your tens times tens. So 6 times 2 is 12 hundredths. This one's going to be for 20 times 3. That's 60. This is going to be for 60 times 8. 6 times 8 is 48 times 10, 480. And last one is going to be my basic fact, 24. Okay, so this box again is always going to have your tens times tens, so it's always going to have 2 zeros in it. These 2 boxes are going to be your tens times ones. They're always going to have 1 0 in it. And then this is going to be your basic fact. And again, this shows your 4 mini steps of multiplications. Your ones times ones, your 10 times tens, but also tens times ones, and these tens times 1 as well, which a lot of students would leave out if we didn't show it to them in a model that gives them a visual of those 4 steps. So to get our final answer, we're going to add up those partial products: 1,200, 480, 60, and 24. Making sure I've copied my numbers nice and neatly, lined everything up. 16. Okay, 1,764. All right, so what we want to show is that what we've really done here is to split up 28 into 20 and 8, and 60 and 3 into 63, and we're doing what's called the distributive property, which means I'm multiplying this 20 times both of these numbers, and I'm also doing the 8 times both of these numbers. And if we leave out any of those steps, then we're only multiplying part of the problem, and we want all 4 parts in order to make it have the right value. So what we did here was 20 times 60 plus 20 times 3 plus 8 times 60 plus 8 times 3. Sorry, I kind of ran out of room there. Okay, so this is showing the distributive property of the values that are multiplied in our partial products. Students don't have to write this every time, but sometimes this is what will appear on their test rather than a final answer. It's another reason we need to practice partial products, because they don't always ask for a final answer. Sometimes they want to know what are the parts that are multiplied, or what are the partial products that are used to answer the question. So we've been practicing this all week, and we will continue before our test next week on Tuesday. All right, thank you so much for your time. Good luck with partial products and multiplication.